The message Elon Musk delivered couldn't have been clearer. Not maybe, not possibly. This change will happen. The teslapiphone has arrived at just $175, and this time it goes far beyond normal smartphones by eliminating carrier fees entirely through lifetime Starlink calling and satellite internet, even in the most remote American regions. Its new oxide-based display architecture, quietly referred to as rule rewriting glass, pushes durability into a new category, while its built-in communication hardware is already aligned for future Martian networks, making it the first device intentionally engineered for use both on Earth and beyond. The question now is whether Apple can realistically match any of this. This analysis breaks the entire story down by examining 3 breakthroughs with technical clarity you won't get from headlines. If real American-made engineering matters to you, subscribe and help us reach 239,759 supporters. We begin with the core issue: how unlimited, always available Starlink connectivity can actually replace conventional cellular service, especially for seniors. The promise of never paying for another phone plan and never losing access to the internet, even in a desert or under a subway line, sounds unrealistic. Yet that's exactly the path Tesla is taking with its free Starlink-based system built for American life and eventually Mars. The real question becomes how a $175 device can deliver unlimited calls, constant internet, and full television streaming without a SIM card while outperforming the iPhone ecosystem in cost and coverage. It starts with a direct-to-device Starlink network capable of roughly 100 megabits per second downlink across 98% of U.S. land, including rural regions where Apple's 5G networks often fail to reach even 70% coverage. All authentication occurs through a laser-linked satellite system using quantum-secure encryption, reducing setup time dramatically compared to iPhone eSIM activation. Over a decade, users avoid more than $1,200 in subscription fees because Starlink eliminates monthly carrier plans entirely. Performance tests consistently show browsing speeds between 50 and 150 megabits per second with no data limits, and around 95% uptime in dense cities like New York, while traditional carrier networks tied to iPhones still suffer significant slowdowns during peak hours. Satellite-delivered television further disrupts old cable models by providing 500-plus channels with sub-20 millisecond latency, a shift analysts believe could move millions away from cable in places like Florida, where monthly bills average $150. In real-world coverage tests, Starlink's beamforming antennas maintain almost perfect connectivity even at highway speeds, reducing drop rates by 40% compared to iPhones. In California's Redwood Forest, the high-frequency band-hopping system sustains around 95% signal despite foliage that cripples standard wireless networks. Indoors, multi-orbit satellite handoff keeps reception above -100 dBm, giving strong coverage inside high-rises where 25% of Apple users still face dead zones. Even underground, Starlink maintains around 75% reliability in New York subway tunnels where iPhones typically lose all connection. Most surprising, all of this is handled by a compact 2-inch phased array antenna inside the phone drawing less than 2 watts, eliminating the need for expensive external Starlink dishes and saving hundreds in hardware costs. On a national scale, this shift could reduce telecom expenses by tens of billions annually, while in the United States alone it could erode Apple's dominant market share as millions adopt a no-bill, always-online model. For seniors living on limited budgets, the freedom from monthly payments and dead zones represents a meaningful improvement in daily life. But connectivity is only half of what Tesla placed in the opening minute of this design. The display technology marks another dramatic leap, one that makes Apple's ceramic shield look outdated. The so-called cyberglass system is built on a modular design where separate display layers magnetically lock together rather than existing as a single break-prone piece. When the device impacts the ground, the shock distributes across the seams instead of concentrating at one failure point, dropping the fracture rate from 80% to under 20% in typical falls. Each layer can be replaced in minutes, cutting e-waste by nearly half compared to Apple's sealed and expensive panels. The nanoparticle-reinforced glass reaches around 1.5 gigapascals in hardness, surviving drops from over 6 feet onto concrete about 95% of the time, whereas top iPhone screens survive only about 60% of similar impacts. High-mobility oxide semiconductors boost electron flow dramatically, enabling 120 Hz refresh rates while using 30% less power than OLED panels. For seniors, that means smoother use, cooler operation, and roughly 2 extra hours of battery life each day. Brightness peaks at 2000 nits for clear outdoor visibility. Color accuracy remains extremely tight, and eye strain drops for long reading sessions, an important upgrade for aging eyes. These oxide layers also tolerate temperatures up to 300 degrees Fahrenheit, far exceeding Apple screens, which begin warping at levels common to hot pavement in southern states. With Tesla's modular system, replacing a damaged layer costs around $20, a huge contrast to Apple's minimum $500 repair fees. Even scratches self-heal through Tesla's microcoating that fills shallow abrasions, making the surface look clean even after months of wear. Combined with slightly wider tactile edges for users with weak grip strength, the display is both tougher and more ergonomic. The same engineering that benefits seniors directly also creates practical advantages for Mars. A device centered on satellite-first communication, modular repairs, and extreme power efficiency becomes naturally suited for a hostile planet where infrastructure barely exists. The Pi-phone can link directly with Starship's onboard Starlink relays to support around 100 colonists without needing towers or repeaters, maintaining stable 20-minute latency through laser-linked satellites. Unlike Apple's carrier-dependent architecture, Tesla's system works where no cellular network ever will. Its oxide-reinforced fiberglass absorbs close to 90% of harmful radiation, giving the device a lifespan of around 5 years under Martian conditions, far more than what iPhone displays manage under normal Earth environments. The same bandwidth-efficient communication that provides stable video calls during hurricanes in Florida enables holographic 4K communication between Earth and Mars using half the data of NASA's current systems. Power efficiency matters even more off-world. Oxide circuitry consumes 40% less energy in low light, enabling the phone to run indefinitely when paired with small solar cells, ideal for long Martian dust storms. For Americans on Earth, that translates into a phone that survives blackouts, storms, and emergencies without draining quickly. Modular repairs that empower Martian settlers also help Americans in disaster-prone regions repair their devices cheaply at home. The broader implications align with Musk's long-term vision. Engineering devices that operate beyond Earth unlocks a new technology category Apple cannot easily enter because its entire ecosystem relies on terrestrial carriers. Tesla's system relies on universal physics, satellite networks, and resilience. Designing at Mars-level discipline results in devices that serve seniors, low-income families, and everyday Americans with reliability that feels revolutionary. As the implications of this transformation ripple outward, the contrast between the two companies becomes sharper than ever. Apple continues refining an ecosystem optimized for yearly upgrades, lock repair chains, and recurring fees, whereas Tesla's deliberately engineering a communications platform meant to last for years, survive harsh environments, and eliminate recurring financial burdens entirely. This shift in philosophy exposes an uncomfortable truth about the broader smartphone industry. Consumers were trained to believe fragility was inevitable. They were taught to tolerate cracked screens, battery degradation, limited coverage, and monthly bills as unavoidable realities of digital life. The Pi phone dismantles that narrative by proving these flaws were never technical necessities, but simply remnants of a business model built on predictable revenue. With a modular display system that anyone can repair, a satellite network immune to local outages, and materials engineering approach shaped by aerospace demands rather than fashion cycles, Tesla undermines the quiet assumptions that allowed competing brands to charge more and deliver less for over a decade. Seniors, who are often first to experience the pain of steep monthly costs and coverage gaps, suddenly gain access to a device that respects their financial limits and accommodates their physical needs with durability, clarity, and simplicity. Even younger users who rely on devices for work, travel, and emergencies benefit from a system that doesn't punish them for living in the real world. And as post-launch adoption accelerates, the cascading effects on telecoms, cable networks, and consumer electronics become impossible to ignore. Carriers dependent on subscription revenue confront the threat of a Starlink-backed model that bypasses them entirely. Cable companies face a future where satellite multicasting outperforms traditional infrastructure with lower prices and wider reach. Repair chains lose their monopoly as modular parts turn everyday people into their own technicians.